Today we are discussing the second topic or second part of the chapter indeterminate form, and we are going to take up the two indeterminate forms. One is 0 into infinity and the other one is infinity minus infinity. And obviously in the previous class we discussed the first two basic forms, that is 0 by 0 and infinity by infinity. So now let us begin. Now in this class we really don't have much to explain because we already have done the explanation, and the only working rule or working formula for solving this kind of problem is L'Hospital's rule or L'Hopital's rule. Now obviously L'Hopital's rule is applicable only when the function or the limiting function is in 0 by 0 form or infinity by infinity form. Now for the other indeterminate forms, I have to ensure that first I take the form into 0 by 0 or infinity by infinity, then only I can make use of the L'Hopital's rule. So let us start off with the first problem. The first problem is limit x tends to 0 plus log x into sin x. Now we have to see which form this is in. Now if you just look at this, when x is tending to 0, sin 0 is 0, so definitely this function sin x, this is going to 0, and obviously log of 0 is infinity, so this is going to infinity. So therefore the given limit is in 0 into infinity form. So now let us see how to deal with such problem. Now obviously I know this, that any limit, given any limit, I can always convert that limit into either 0 by 0 or infinity by infinity form. In this case you can see the sin x, I can write it as cosec x, 1 by cosec x, and so my given limit becomes infinity by infinity form. And once it becomes infinity by infinity, then I can make use of the L'Hopital's rule. So now let us do the derivatives. This is what the derivative looks like. Now after this I need to do some reconstruction, or I need to do some modification to this function. So I can write it something like this: cosec x goes up, it becomes sin x, cot x goes up, it becomes tan x, and 1 by x is going to the denominator, it becoming x. So now once again let me apply the L'Hopital's rule. Let me do the derivative, and so this is what it becomes. Now the indeterminate form is removed, I can put the value of x and I can calculate, and so my answer is 0. So basically from here on, for all the other different forms, I have to ensure that first I bring the limit into 0 by 0 or infinity by infinity, then I can work it out. So let us move to the second problem. 1 minus x into tan pi by 2x. Once again, if I put 1 minus x becomes 0, and tan pi by 2x becomes tan pi by 2, which is infinity. So this is once again in 0 into infinity form. So let me do something. Let me take this tan pi by 2 in the denominator, it becomes cot pi by 2 x. Now once again let us do the same thing, let us do the derivative. So if I do the derivative, this is what it becomes. Now I can see in one derivative itself the indeterminate form is removed. So let me just put the value and calculate, and so this is the answer. Right? Simple enough. Next, problem number 3. Now here, this is a different form. So let us just check what happens. If x tends to 1, log x tends to 0. Obviously, log of 1 is 0 and 1 by 0 is infinity. So this function goes to infinity, and obviously 1 by x minus 1, 1 minus 1 is 0, and this also goes to infinity. So therefore this limit is in infinity minus infinity form. So let us see how to work with infinity minus infinity form. Idea is almost the same. So let us first take the LCM. So if I take the LCM, this is what happens. Now you can check by putting the value of x in the limit. The numerator goes to 0 separately and denominator goes to 0 separately. So I have my standard form, that is 0 by 0. Now I can apply L'Hopital's rule. So let us go on doing the derivative. So after first derivative itself, I can see it is still in 0 by 0 form. Just check on the derivative. I am not doing the I am not explaining the derivative, nothing to explain there. Then let us do the second derivative. So after doing the second derivative, this is what we get, and hence I have my answer. Putting the value, I get the answer. Right? Clear enough? Then problem number 4. Now problem number 4, before we go on dealing with this problem, let me tell you, this problem looks very cute because it is simple. Cosec square x minus 1 by x square. It looks very simple, obviously, but it is definitely not that simple to solve. So once again, let us do some checking. Cosec square x, obviously, as x tends to 0, cosec x is infinity, so cosec square x also tends to infinity, so this goes to infinity. And obviously 1 by x square also goes to infinity. So therefore this is in infinity minus infinity form. Now let us start off. So now cosec square x, I can write this as 1 by sine square x. Simple. Then let me take the LCM. If I take the LCM, I get x square minus sine square x by x square sine square x. Now from here, if I want to do the derivative, if I can go on doing the derivative, I can, obviously, because I have already got the 0 by 0 form. But just for your understanding, you just see I have a sine square x term, and every single time I go on doing the derivative, it will become bigger and bigger and bigger. So therefore working with sine square x is difficult. So therefore let me do one small trick. Let me do what? Let me apply a plus b into a minus b formula. So x square minus sine square x, I can write it as x plus sine x into x minus sine x. Right? Now then I am doing what? I am dividing the x plus sine x with 1x from the denominator. So I can write this as 1 plus sine x by x. Don't mind the noises in the background because I am not at home, I am somewhere else. So sorry for all the disturbance that is happening. Now 1 plus sine x by x, I can always bring it out of the limit. How? Because 1 is 1, it is constant, so it comes out of the limit naturally, and sine x by x, as limit tends to 0, is also 1. So therefore 1 plus 1, it becomes 2. So in the next step, I have already taken out that first term, that is this one. I have already taken out this first term, and it becomes 2. Fine. Now for rest of the thing, I can go on doing the normal derivative. So let us do the normal derivative. So after one derivative, this is what happens. Now x into sine square x derivative, the derivative of sine square x is sine 2x. Now if somebody has doubt, so let me just explain. ddx of sine square x, it will be 2 sine x cos x, which is basically sine 2x. Fine. So I can directly write ddx of sine square x is sine 2x. Similarly, ddx of cos square x is also minus sine 2x, which you can check easily. Now after doing the first derivative, I can see it is still in 0 by 0 form. So let me do the derivative once again. So after doing the second derivative, still the 0 by 0 form persists. So I will do another derivative for the third time. And after doing the derivative for the third time, I can see the indeterminate form is removed. So I am not explaining the derivatives. Please check the derivatives once for yourself. Now, once the indeterminate form is removed, now let us put the value of x, do our calculation, and so we get our answer. Right? So that's it. This is our whole class today. Not much to explain. Why? Because we have already done our theory part. So you can see how to deal with 0 into infinity form and infinity minus infinity form. Obviously, infinity minus infinity form being a little bit difficult, because you may come across expressions which can become very big, and while doing the derivative, it can become a little bit complex and bigger itself. So therefore, you have to do it a little bit patiently. The derivatives you have to do a little bit patiently. And also, the trick which I applied here by breaking up the factors, if you possibly can see that you can make your expression simpler by doing so, then definitely try applying that first and then go on using the L'Hopital's rule. Fine. So thank you so much. And also, as it is told that your classes will continue even after 15th, so I will continue taking the class, and I am trying to complete this chapter by next week, because I am taking 2 classes every week. So this is the second class of this chapter, and the third and the fourth class will be taken next week. And so if I finish off the chapter, I assure you I'll leave you for the next week, so you can take a break and also cover up the things which you are yet to cover up. So anyway, thank you so much. Let us meet in the next class.